Hello, everyone, and welcome to another SETI Live. I am your host, Beth Johnson from the SETI Institute, and with me today is Dr. Candace Hansen. Candy is a senior scientist at the Planetary Science Institute and a co-investigator for the Juno mission. She is responsible for JunoCam operations, and she is here today to talk about some of the science and most importantly, to talk about the citizen science project for JunoCam. As always, we want to welcome everyone to our stream, no matter where you are watching. Please let us know where you are watching from so we can give you a shout out. And as a reminder, we are a 501c3 nonprofit, and we are supported in our outreach programs by your generous donations. So feel free to throw up those bits, subs, stars, and super chats. We really appreciate all of those. And let's get started. Thank you, Candy, for joining us today. How are you?
Good, thank you.
So you are a co-investigator on Juno. Can you kind of give everybody a little bit of a rundown on what the Juno mission is and what its primary missions are?
Yes. Juno is a robotic spacecraft. It's in orbit around Jupiter. We went into orbit in 2016. It's a different mission because from ones we've done in the past, because the spacecraft is in a polar orbit. And being in a polar orbit allows us to really investigate the gravity field and the magnetic field and take pictures of regions that have never been seen very well anyway from the Earth or from other spacecraft. And that's the polar regions. Most other past spacecraft have either flown by Jupiter or orbited in its equatorial plane. And so we are flying over the poles instead. The orbit was 53 days long. And so most of our exciting time is right when we're close to Jupiter, which we call perijove. And we take pictures for about a day, roughly around perijove, a little bit less than that. And so it's once every 53 days, we have a very exciting time. And in fact, today happens to be our 36th perijove pass. And we've just started getting our data down from the spacecraft. So it's really exciting still because on every pass, the geometry changes and we get new data and new looks at what's going on at Jupiter. So I'm responsible for the camera, and our science objectives really did not require a camera. Our required payload was the magnetometer, microwave radiometer, a lot of instruments to measure the radiation environment. And so the camera, because we didn't have a driving science objective, we were free to create the citizen science experience that we've been putting out for you all for the last 5 years. And we just got the approval from NASA to go on for an extended mission for another 4 years.
And that extended mission is going to cover some more interesting flybys, correct?
Yes. The orbit is an ellipse, and as time has gone on, the southern end of the ellipse has been going more southward, and the perijove point has been moving northward. So what that means is that now, instead of never getting close to any of the Galilean satellites, we are in fact starting to cut through where their orbits are, and we've designed it so that we can get a couple of close flybys of each one of them. So that'll be new. And then with our fields and particles instruments, we're exploring territory that's closer and closer to Jupiter as time goes on in that equatorial plane, where things like Io's Taurus and things like that, exciting stuff for Jupiter happens to be. And then ultimately, towards the end of the mission, we will get inside the rings, and that'll be interesting too.
Oh, I'm looking forward to that. Of course, I'm also looking forward to images of Io, but that's clearly my thing. Before we go on, let me give some shout outs. We've got some locations rolling right in here. So we've got people watching from the United Kingdom, California, Canada, Nicaragua, Arkansas, India, Mexico, Ireland, Pennsylvania, Australia, Denmark, Spain. Someone apparently is watching from Europa, so welcome, and from Portugal. So we've got a pretty global and possibly even a solar system wide audience today. So that's pretty cool. So Candy, what is the citizen science project aspect of JunoCam?
Yeah, if you don't mind, I'll share my screen.
Absolutely, please share.
Okay. We have a portal, a website that is called Mission Juno, and the URL is here on this slide, and I believe it's also in the chat box. And what we do, actually, for this audience, I'm actually going to back up a little. What we decided to do, since we didn't have a science team, is we decided to invite everyone in the world to be members of our team and participate, not just watch what we do, but actually be a part of it as well. And so we said, okay, what does a sort of a classic imaging team need to do, and how will we do that with the world? And so we set up 5 different ways to get involved. Planning, which is the amateur astronomy community gets involved at this point by sending us their pictures of Jupiter. Since we're in this 53-day orbit, we only get close. We don't know what's going on for 52 out of the 53 days. So the amateur astronomy community has been very important in sending us their data. We have discussion and voting, which are not as useful as it turns out, even though at the beginning we thought they would be. But the one that's really been the hit is the image processing page. And that's what I'll show you. I'll show you the wonderful contributions people have made. And of course, all of you on the line are invited to get involved here too. Of course, if you happen to be an amateur astronomer, go to the planning page. But if you like to mess around with Photoshop, this is your home. We have 3 galleries at this particular page. The top one is the most recent data from JunoCam, so from Jupiter. So in a couple of days, we will have the images up from this pass that we're making today. We have to wait for the data to get downlinked, and then we run it through our pipeline, and then we post it. And I'll say in a minute what that is. Featured submissions are some of our favorites. And then the 3rd gallery is all of the contributions that amateurs around the world have made by picking up our data and doing their own processing. So I'll show you some examples of that. So first of all, this is what we post. We post our raw data. Some of our contributors like to start at the very beginning, and they have their own processing pipelines. Most people either start with the color reconstruction or the 3 monochrome images. So we take red, green, and blue images through our 3 filters, and then we map, project, and put the color construction, but then we stop. That's about what our team, that's where we stop and let you guys take over. So this is an example where just really using Photoshop, this is what people do. So the raw image is on the left, and then a processed image is on the right. And that's what we invite everyone to do. We love, love, love to see your contributions. I do want to remind everyone that Jupiter, if you look at it through a telescope, it's got this beautiful subtle palette. And it's rare, actually. Most of our contributors enhance the color, and we love enhanced color, don't get me wrong. But this is what realistically Jupiter would look like. Now, it turns out that when you do color enhancements, all these same features survive. They're just a little easier to see. So just to give you an idea again about the geometry in this polar orbit, most of our time we spend quite distant from Jupiter. And so our best views are taken in this 2 hours around closest approach, around perigove. That gives us some very unique imaging geometry, because as you can see, we go from over the North Pole to over the South Pole in 2 hours. And we're really just skimming the cloud tops right at closest approach. So what that means is that when we're standing off over the poles, we see all of Jupiter. But when we're very close, we're just seeing a teeny tiny piece of it. And that's also a very unique perspective that previous missions have not had. So when we put our images all together, it looks something like this. So if you're an Earth-based observer or you were on a different spacecraft, a previous spacecraft, you can see the whole globe. Whereas if you're riding along with Juno, you see all of the northern hemisphere that's illuminated, so that's half. And then you get this really quick swath really close to the planet, and then you see most of the southern hemisphere as the spacecraft goes by.
Oh,
So,
wow. That's really unusual. I like that.
yeah, it's different. It's very different from previous missions.
So some of the, let me just
Yeah,
ask you a
go ahead.
question. Some of the people that I've seen a lot of their work. So like Kevin Gill,
Mhm.
Shan, Gerald Eichstecht,
Yeah,
they're all doing a lot of this processing, and their images get
yes,
pulled and publicized everywhere, it seems.
yes.
I don't want you to play favorites, but are there any particular like types of images that you enjoy looking at out of some of this? I've seen some where it's, you know, the color processed images, but I've also seen some interesting takes, sort of an artwork. There was one I saw that they had done it where it looked like it was painted, so it had the appearance of brush strokes in it. So
Yes,
what kinds of images have really caught your attention?
yes. So that's very true. And I'm showing you now on my screen an example. So the first image that you see is the processed one through our pipeline. Gerald, who you mentioned, he flattens the lighting so that it doesn't matter if you're looking close to the subsolar point or close to the terminator, the day-night boundary. So he does that. Then quite often, Sean will pick up Gerald's products and do an enhanced color project. And then this one on the right by Lucy West is actually an oil painting. So yes, it's very, very cool what people have done.
Wow. Okay. So that was exactly what I was thinking of. It's really nice to see the process from one person to the next to the next. That's kind of what we're sort of asking people to do. So one of the reasons that I have Candy here is, some of you may know that we have an art imaginarium group on Facebook, and we've had a delay. We wanted to introduce Candy's project last month, and there were some technology problems, and then we got the SETI Live scheduled, so we're kind of rolling it all together. So after this SETI Live, one of the things that's going to happen is, for the rest of the year, because we're going to switch our challenges to sort of quarterly, we want our artists and astrophotographers to participate in this project. So obviously for the astrophotographers, we want you to go out and help with the planning. And then for the artists, we want you to kind of dig in and take these images and make them art, process them however you want to. And we want to see those. And Candy, obviously you want them to upload those into the gallery so that they can be shared.
Yes, that's exactly right. And I am now showing one of my absolute favorites. This one is by Rita Najim. I'm probably butchering her name, but one of my favorites. And you asked me about that, but it doesn't have to necessarily be something like this. I mean, we have other examples that are, it looks like someone made I don't know, like it's being like Jupiter's being eaten. And here's another one of my favorites, Jupiter in someone's hand. And another one of my favorites, the dolphin. So I guess you can hopefully see the little dolphin in the clouds there. And then the guy, staring out the window and taking a picture of it on their iPhone, right? So people have so much imagination. Here's another one of my favorites, going more back to Jupiter itself, but now as a work of art rather than as an image.
Oh, I like that. That's really pretty. It's an interesting color palette choice too.
Yeah, yeah.
But it brings out those storms. It really makes them pop right out of the clouds there.
Right.
Wow. So these are the kinds of things that people can do with this project. So let me give a few more shout outs here. So we have Ohio, West Virginia, Turkey, here in the San Francisco Bay Area, Oklahoma, and someone else from the United Kingdom. So welcome everybody once again. I am here with Dr. Candace Hansen. She is the operations person for the JunoCam aboard NASA's Juno spacecraft. And we are talking about the citizen science aspect of the project and our call for art submissions to our Art Imaginarium project, and also to JunoCam, obviously, so that we can share all of these. I feel free to ask questions of Dr. Hansen while we're here. We've got a few minutes, and I've got one that's already come in. So what are the main objectives that you guys are looking for the next few years?
Well, we want to continue to study Jupiter's magnetic field because, of course, it wasn't as simple as everyone expected. And the same can be said of the interior of Jupiter. We learned so much in the prime mission that we now have the opportunity to follow up in the extended mission. There's this very intense region of the magnetic field that actually seems to be pretty close, relatively close to the surface. We call it the Great Blue Spot because it's like blue lines that intersect if you draw the contours, right? Mm-hmm. And so we'll fly over that a number of times to try to study that magnetic anomaly, if you will, although it's probably not anomalous for Jupiter. And then, of course, as I was describing, we start crossing the Galilean satellites. We already, in fact, flew by Ganymede and right. Got some really great images of Ganymede for the first time since Galileo flew by. So between Galileo and Voyager, Ganymede had been pretty well imaged. But what we found when we flew by, we mostly saw terrain that had been covered by Voyager. And what we realized, and I'll just show the picture, is that in fact, the quality of our images, even though the resolution was similar, the quality of our images was so much better. And I actually went back and looked at, because I was on the Voyager imaging team at the time working for them. I actually went back and looked at my notebook from those years and found that I had indeed jotted down this image is smeared, this image is smeared. And so there's a more sort of crystal clear nature to our images because they're not smeared. And so when you zoom in, you can really see a lot of the detail it's also there in the Voyager images, but it's blurry. So anyway, and you mentioned Kevin and you mentioned Gerald, and these are two of from their work.
Wow.
So we really do, it really truly is citizen science and a virtual team. These are not members of the Juno mission flight team. Mm-hmm. These are members of the public who are, just passionate about being part of our virtual team.
Right. And I'm really glad you shared some of the image of Ganymede, because when we talked about that, but when you and I have talked previously about this, and you had mentioned that Galileo actually had better images of Ganymede for you to make comparisons to than the Voyager mission did. Have you guys been doing some of those comparisons?
Yeah, we're working on it. Those things take time because you do have to go back to the original data. We thought, actually one of our amateurs thought that he had detected a new crater, which of course would have been very exciting. But it turns out that it was actually there in the original image. It was just that, what's available in the maps and things, that are easy to find on the web. It didn't, whatever processing had been done had lost that spot. So yeah, so that part takes a lot more careful comparison. And
What's
so
the
therefore it takes time.
I'm looking forward to the results of that. What science results? I know you're working on the JunoCam side, but I also know that you're very aware of what's being discovered elsewhere on the spacecraft with all the various instruments. What's been the most interesting or even, surprising results so far?
So I've mentioned the structure of the core is different than what we've expected, and the same thing with the magnetic field. But I actually do want to highlight a JunoCam, sort of what you might call a discovery. And I'm afraid I might not have a good picture of it here. It's something that we call pop-up storms. And what they are is tiny, tiny, tiny storms, except that it's Jupiter, so it's really not all that tiny. Let me see if there's some in here. That's not my best one. Okay, this will have to do though. But you can see these bright white spots, and especially right up here. These were in the older data from older previous spacecraft, but they weren't real obvious. And part of the reason was because if you looked at a Voyager or Ganymede image, you only saw a little postage stamp. And so what you didn't see is that they're sprinkled all across this latitude band. And so having the big wide 58-degree field of view of JunoCam allows us to see how many of them there are and more of the context of what storms do you see them, what storms not. So these pop-up clouds are really, really, really cool. And then the other thing that we discovered with JunoCam and not expected is that at the North Pole and at the South Pole, there are cyclones. And so I'm showing you now.
Wow.
There are 8 around the North Pole. And then there's one in the center. Now, the North Pole's been a little bit hard to image because it's been in polar night. The tilt of Jupiter is only 3 degrees. It's not like the Earth where we are tilted 23.5 degrees. So the poles are mostly illuminated except for that little 3 degrees of polar night. And so it took us a while to actually realize for sure that there was a cyclone at the pole. But we've been watching these 8 around the pole, and to see, they sort of jostle each other and move away, and then they've come back in, and it's still at the number 8 after 5 years. But what's happening is because the closest approach point is moving closer and closer to the northern pole, we're starting to see these guys in just exquisite detail. And so first of all, that was one of our discoveries when we first got to Jupiter. And since then, it's been an ongoing investigation.
That is fascinating. I have missed some of these images, so you guys are going to see some of these images in our social media coming up soon, I'm pretty sure. How many more years is JunoCam and Juno is that going to be active? What's the extended mission for, and how long can you get realistically?
Well, we're going out to 2024, 2025. The spacecraft, we were worried about the radiation environment, of course, but the spacecraft is very healthy. And so we're pretty confident that we will be able to do the entire extended mission. And who knows, maybe 4 or 5 years from now, we'll be writing another proposal for another extension.
I hope that's the case. Okay, so we're going to wrap things up. For those of you who are interested in joining the Art Imaginarium, I understand that we've put a link in the chat for you. We will get to your membership requests. Please make sure you fill out our membership questions and agree to our rules. It's very important. The moderators will take a look through those and admit people as they see them. And we're really thrilled that there's some enthusiasm for that. If you are not a Facebook person, that's perfectly fine. You can join our Art Imaginarium challenges on Twitter and on Instagram simply by using the hashtag Art Imaginarium. And I go looking for those. So I will find them and I will share them back out. Candy, what are you looking forward to right now? Like what's in the front of your mind? What's the first thing you think, this is what I'm excited about?
Well, every Perijove pass, I'm very excited to see what does Jupiter look like now. But there's also, there's certain things we're following along. Some of the storms, how they develop, how they dissipate. But really, I guess next on my excitement list will be when we make our close Europa flybys.
Oh, so exciting.
Yes.
All right. Well, I'm going to look forward to that and look forward to whatever comes out of this latest Perijove too. So I'm going to be keeping a close eye on the image galleries. Thank you, Candy, for joining us today. It's been a pleasure as always. Thank you everybody for watching. Once again, just as a reminder, we are a nonprofit and we do appreciate all of your donations. If you want to go straight to our website, SETI.org, you can check there for all of our news. You can sign up for our newsletter and you can make a donation straight to the organization there as well. Also coming up next week, our SETI Live will not be on Thursday. So I want to give everybody a heads up of the schedule change for next week. We will be live on Wednesday, September 7th at 2 p.m. Pacific time, which is 5 p.m. Eastern and -7 UTC. Bettina Forget, our SETI Artist in Residence Director, will be talking with Theater Me Too about their latest production, which is called Utopian Hotline. So that's going to be a really interesting one, a little bit more of our science and art theme going around here right now. So we will be really excited to have all of you back there for us next week, and just kind of keep an eye on all of our social media for announcements of other events and podcasts. And Grudge Report is kicking back up, and so we will see you guys through all of the things. So thank you everybody for watching, and once again, Dr. Hansen, thank you.